Elon Musk's SpaceX is changing the aerospace industry in the same way as Tesla has changed the car industry. SpaceX's workhorse rocket, the 70-meter-tall Falcon 9, has already shaken up the aerospace business. With that rocket, SpaceX pioneered reusability, employing retro rockets and steerable fins to guide the first stage to a landing after it re-enters the atmosphere. But Musk still wasn't satisfied. That's why Starship, a new generation rocket, was born. Known as the tallest and most powerful super heavy launch vehicle ever built, Starship is Musk's multi-billion-dollar bet to carry both cargo and people to Mars. It's a giant rocket system that's twice as powerful as the Saturn V that carried astronauts to the moon. By using a fully reusable system that has cheap fuel, cheap launch costs, can be refueled in orbit, and can synthesize new fuel in Mars, Starship could totally change the way Mars exploration works. But it has to reach orbit first. SpaceX's current goal is to qualify the first Super Heavy booster for flight. To do so, SpaceX must static fire a Super Heavy with 33 all-new Raptor 2 engines, generating a total of around 7,600 metric tons of thrust. Fortunately, many signs indicate that SpaceX is upgrading everything for this historic static fire testing this week. Without any delays, let's get started in today's episode of Great SpaceX. Booster 7, a prototype first stage of the Starship system, passed 2 single-engine static fire tests on the orbital launch mount in early August. After testing Booster 7's outer engines, the vehicle's return to the production site looked set. The SPMTs were on their way to the launch site. The LR-11000 crane was moved and the load spreader attached to Booster 7 before the lift occurred. The Super Heavy booster was then rolled back into the Mega Bay. There, SpaceX teams have been preparing B7 for further static fire testing via the installation of the inner 13 engines, bringing the booster back to its full 33-engine set. Super Heavy B7 is likely to be rolled out in the next few days, and it's really worth the wait. Elsewhere at Starbase, crews have been repairing and upgrading pad systems for upcoming tests, as well as future flight plans. Typically, new pipes have been installed for what is believed to be a new engine chill system on the OLM. The installation plays a very important role in the upcoming tests, especially with the epic static fire test on the B7. Now, why is that exactly? Let's step back in time to last July on the 11th. It must have been a terrifying day for all SpaceX fans when a rumbling explosion ripped through SpaceX's rocket test facility in Boca Chica, Texas. The incident began around 4:20 p.m. CDT when SpaceX's Super Heavy Booster 7, or its launch mount actually, unintentionally ignited a cloud of flammable gas produced during the flow test involving most or all of its 33 Raptor engines. When the resulting cloud of well-mixed methane and oxygen gas was accidentally ignited, it functioned like a small fuel air bomb, rapidly combusting to produce a violent explosion and shockwave. After the initial explosion, the fire also expanded to burn as much of the resulting gas as possible, producing a fireball that briefly reached 80 to 90 meters in height. And it's believed that methane flow during engine chill down was the primary cause of the elevated quantity of methane in the air, causing that unexpected fireball. And installing this new set of pipes will most likely help prevent that unfortunate situation from happening again. Although it debuted first during the recent tests on B7, further work has been ongoing for the past few days. As a quick note, these pipes may aid SpaceX in testing B7 with all necessary engines installed this week, but it appears that this system is not intended for use during launch because it requires the engine shields to be removed in order for these pipes to access the locations of the engine bleed system. In any case, we don't need to worry very much about that, because according to some sources, SpaceX may very well have had the system to recapture these vapors of methane from the engines. but had not yet fully employed it due to the immatureness of the ground systems to reliably conduct this process. Not only the OLM, but SpaceX's chopsticks are also being upgraded for welcoming the return of the B-7, as well as gearing up for the first attempt of a booster catch. The hydraulic system was repaired over the past couple of weeks, and we're glad to see it in working condition again. Interestingly enough, hydraulic pistons were installed on the chopsticks, and here is a good view captured by Kevin Randolph, the official photographer for What About It. As always, huge thanks for his hard work. According to Randolph, this upgrade aims to set the stage for a first attempt booster catch for the upcoming Starship launch. The pistons will also help the actuators move the rails up ahead of a catch attempt and, once the booster has landed and its position has been centered, help lower the rail for installation of the booster back onto the OLM or transport stand. In addition, Raptor 2 testing will begin to speed up on this super heavy prototype. SpaceX has test windows scheduled on August 23rd, 24th, and the 25th, showing that the company intends to perform at least one more static fire test in the coming days. The question then is, will SpaceX gradually increase the number of engine static firing or go full on in with a 33 engine static fire? Logically, it would make sense for SpaceX to conduct multiple static fires with a gradual increase of engines. However, one comment from Musk could change everything. As SpaceX continues ground testing of its Starship Super Heavy rocket in preparation for its first orbital flight, the company has reached a new milestone. On August 19th, SpaceX launched the Starlink Group 4-27 mission, which was the 25th launch of a group of 53 satellites into orbital Shell 4. Friday's launch boosted the total number of Starlink satellites launched to 3,108, of which around 2,844 remain in low Earth orbit, according to data by leading astronomer Jonathan McDowell. Besides that, this launch also marked the 9th flight for the Falcon 9 first stage booster identified as B-1062-9, which previously launched the U.S. Space Force's GPS-3 Space Vehicle 4 and GPS-3 Space Vehicle 5, SpaceX's all-civilian Inspiration mission in September of 2021, the Axiom AX-1 Crew, Egypt's Nilesat 301 satellites, and now a total of 4 Starlink missions. To date, SpaceX has landed 137 orbital-class rockets and reused first-stage boosters 113 times. Being capable of reusing Falcon 9 boosters enables SpaceX to conduct frequent, cost-effective space flights. And that's it for today's episode. We thank you so much for watching, and if you enjoy what my team and I are doing, you can become a patron through our Patreon link in the description below. Otherwise, as always, this is Kevin with Great SpaceX, and my team and I will see you next time.